Hello everyone, my name is Navneet Prada and in this video I am going to explain my AIML project StudyMine AI Pro. Okay. StudyMine AI Pro is an AI powered PDF question answering system designed for students. A main purpose of this project is to allow a user to upload their own study material in PDF format and then ask questions about the document. See, instead of manually searching through a large PDF, the user can simply ask a question and the system retrieve the most relevant information from the uploaded document and uses Google Gemini to generate a clear answer and provide the user. The main AI concept implemented in this project is retrieval augmented generation or RAG. In this video, I will explain the project idea, technology used, project structure, implemented code file, the complete RAG pipeline, and finally, I will demonstrate the working website. Okay, in this video, we will completely discuss about this project, how I make, and what is the main work, what is the main concept used in here. Okay, let's start. Students often have large PDF file containing notes, textbook, study material, or documented. Finding a particular answer manually can take a lots of time. So I created this study system where the student can upload the PDF once and then interact with the document using natural language. Means it is the basic feature of my project where a student can upload his file or document in PDF format and ask question or interact with the AI. um, whatever in the whatever details in the document, it can interact with them and get the answer from it. Okay, but for example, instead of searching for keywords such as surprise learning, the user can ask, what is surprised learning? The system then finding the relevant information from the uploaded document and generate the answer based on the information is called the surprised learning. Okay, that's clear. Then we will go to the features part. Okay. First, first feature is the PDF knowledge base. The user can upload the study material in PDF format and the system processes their document and convert it into a searchable knowledge. Second is context aware answer. The AI does not simply answer the question from its general knowledge. It is fast retrieve relevant information from the uploaded document. And third is semantic search. This means the system search based on the meaning of the question instead of depending only on exact keyword. Means here three. No, let's move forward. And fourth is Gemini. Gemini is used to generate the final natural language answering using the retrieved document context. Means here we use four type of features. First one is to put the PDF in input or upload a PDF file or whatever document have the student, it can upload here. And second is context our answer. AI does not simply answer the question, it is generate the means it collect the information from the document and make its relevant information and give the answer to the student. Then semantic search you can know, and Gemini, through Gemini we can modify the language or simply language we provide the learner who can understood well. Then we will go to the next part. I will show the project features, what is the project, why I make it, and we'll go to direct the code part. Okay. This time the project is running away. Now I'll explain the technology stack used in the project. For the front end, I use React and TypeScript. Front end, React and TypeScript and Vite. I use Tailwind CSS for styling and Louis React for icons. For the backend, I use Python with Fast API. For PDF processing, I use PyPDF. For converting text into embedding, I use Sentence Transformer, especially the ALL Minlin L6B2 model. For storing and searching the embeddings, I use Chrome DB database, which work as the vector database. Finally, I use Google Gemini to generate the final answer. So the overall architecture is React frontend, fast API backend, PDF processing, chunking, embedding, Chrome database, simply search, Gemini, and final answer. That's it. Okay. As like you can see the folders and file format as here. This is the overall structure of my project. I have divided the application into two major parts, the front end and the back end. The src folder contains the React front end as src. It is contain the React front end, and the backend folder contains the fast API server and completely RAG pipeline. Instead, the backend I created a separate RAG folder because I want to keep the different stage of RAG process organized. The important file are loader.py. See RAG file I will show. This is the important files here. Is the loader.py, split.py, immediate.py, vector store.py, and retrieval.py. Each file has a special responsibility. It is the important part or important concept here, which is used here. Okay, so let's start from the front end. All the front end part is in the src folder of this. Okay, now let's look at the front end. The main front end file is app.tsx. At the beginning, I import React hooks such as use state and use ref. Okay, at the first part we import the React. Use state is used because the application has dynamic information such as the uploaded document, the question, the generated answer, loading state, and error. Useref is used to controlling the hidden file input when the user click the browser file button. Okay, this is all about this line. Okay, then features and workflow. I created array called features and workflow to keep the website context organized. Means to make the context in organized format, we created features workflow. Instead of writing every features manually in the JSX, I store the data in array and render it dynamically. This makes the front end easier to maintain and modify. Okay, move forward. See, wait. Okay, look at the functions. This function. These are some of the most important state variable in the application. Documents state information about the uploaded PDF. Question store the question entered by the user. Answer store the response received from the backend. Loading tells the interface that an AI answer is being generated. Uploading is used while the PDF is being processed, and the error stored error messages that can be displayed to the user. React state allow the interface to automatically update when their values change. Okay, this is all about this function and the main important things here. You, I think you know. I hope you understand. Look for at this function. The function handles PDF uploading. First, the error state is clear. Then the application check whether the selected file is actually a PDF. If it is not a PDF, the user received an error message. Then the uploading state is enabled. The file is sent to the backend using the upload document function. When the backend successfully proceeds the PDF, the written document information is stored in the React state. We'll go to the next part and check part where uncheck where and check where. Okay, it is upload. We discuss about the upload and upload function. We'll now go to the hand ask. What is tell the hand ask function? The function is responsible for asking question about the uploaded document. First, it check whether the user has entered a question. Then it is send the question and document ID to backend. While the backend is processing the request, the loading state become true. Once the answer is retrieved, it is stored in the answer state and displayed in the screen. Okay, sorry to interrupt. So let's move forward to the final touch of this project, that is API file. See, SRC service, then API.ts. Okay. Instead of writing API request directly inside the UI component, I created a separate API.ts file. This keeps the front-end code cleaner and separated the user interface from backend communication. Okay. Instead of manually doing, it is from interact with the backend. See this. Okay. I defined slash API as the base path using the backend export. It is ends its endpoint under this path. Okay. In this path, it is the endpoint where the user can interact with the backend. Next part is uploaded API. Export assigns. In this function, look up this function. What is telling us? This function send the PDF to the fast API backend. I use from data because I am uploading a file. This file is added using the file field and then sent through a post request to API upload. It is send a request to the API upload. When the API give the permission, then the PDF file is uploaded there and send the request to give the response from them. Then fetch. Okay, then we understand about the uploaded document. Now ask document. It is the ask for this ask the question. Okay, this function send the user question to the backend. Here I used a JSON request because I am sending structured data rather than a file. The request contain the question and the document ID. The document ID is important because it allows the backend to search the correct uploaded document. Okay, I have you understand. In this part, in the next part, we will discuss about the TypeScript type. src type, then story.ts. Okay, this file contain TypeScript type used by the frontend. For example, the document record type defines what information the document should contain, such as its ID, file name, size, status, number of chunk, and creation time. The answer response type defines the structure of an AI response. It contains the answer, the source, and whether the answer is grounded in the uploaded document. Using TypeScript type helps make the frontend more predictable and reduce error when handling API response. In the part, let's go move forward fast to the backend part. In this backend main.py backend. Backend. It is the important file here. I describe the backend. Now we move to the backend. The main backend file is main.py. I used Fast API to create the API server. Fast API receives request from the React frontend and connects the request to the RIG pipeline. This program for that. Okay. This important provides the tools required to create the API, receive uploaded file, and handles HTTP errors. In this place, we will use the Google API file what is we generate from the Gemini. Look for this line. Here I created the fast API application. I also configure codes so that the frontend can communicate with the backend during the development. In this process, the frontend can communicate with the backend. That's why the response comes to the face of the programmer. Sorry, user. See this. Codes stand for cross organized resource sharing. It controls which frontend organs origins are allowed to communicate with the backend. Next, move forward the next part. Ask request model. Okay, ask request model. Ask request. Here I define the exact structure of an ask request. The user must provide a question while the document ID is optional. Then ask question, upload question. The endpoint handles PDF upload. First, it verifies that the upload file is PDF or not. Then it create a unique document ID sharing UUI ID. The PDF is saved inside the uploaded directory. After that, the most important part of the RAG pipeline begins. First, the PDF is converted into text page. Then the text is divided into smaller chunks. Then the chunk is converted into embedded and stored in Chrome database. Okay. Document will search art document. Where is art document? Super. In the part of the add document function, here I generate embedding for every chunk and send those embedding to the vector store. Finally, the document information is stored so that the frontend can display that the document is ready. PDF backend RAG loaded the UI. Discuss about these things. Now let's look at the first stage of the RAG pipeline. The file is responsible for extracting text from the PDF. I used a PDF reader class from PyPDF. In this line, it is show us the PDF is opening use RDF reader. Then I loop through every page and extract it text. Then the important things here is that I don't only store the text, I also store the page number. This becomes useful later because the application can show the user where the retrieved information come from. It can store means it can store the page number. Then it is show also the page number where user can also in manually check from the document which is he upload in that in this in my website. Okay, in my program. Then splitter.py. In this fact, after extracting the PDF text, the next step is chunking. Large document cannot be efficient searchable as one huge block of text. So I divided the text into smaller chunks. In my implementation, the default chunk size is 900 words with an overlap of 120 words. Okay, the function is this one is my function. Okay, okay. The overlap is important because it prevents the important information from being lost between two chunks. For example, if an explanation starts near the end of one chunk and continues into the next chunk, the overlap gives the second chunk some context from the previous one. Then we will go to the embedding AI. Now, reach one of the most important AI concept in this project, embeddings. And embeddings convert text into a number vector. This allows the system to compare the semantic meaning of different pieces of text. Look for this. Here I load the all Ming LML6 B2 sentence transformer model. This model converts text into numerical representation. And so see the function. The embedded function accept a list of text string and convert them into vectors. I also normalize the embedding so that similarity comparison works consistently. Okay, then com database and vector store. After generating embedding, I need somewhere to store them. For this, I use Chrome database, which is a vector database. The purpose of the data vector database is to store the embedding along with the original text and metadata. See this line. Here I created a persistent Chrome database client. Persistent means the vector database is stored on disk rather than existing only temporarily in memory. See this. Why about this? I then created a retrieve a collection called StoryMind as documents. Let's discuss about this program. The function adds the document chunks and their embedding to Chrome database. Each chunks gets a unique ID. I also store metadata, contains the document ID and page number. Then metadata, where is metadata? Metadata. See, metadata. This metadata is important because later I can restrict the search to the specific document and also identify the page where the information come from. Okay, then we'll go to the search part. This is the search function. When a user asks a question, that question is also converted into a embedding. Chrome database compares the question vector against the stored document vector. It is then return the most similar chunks. In this project, I retrieve of the first relevant result. Okay, it is the result part. Okay, I hope you understand. So here condition allow me to search only inside the selected document when a document ID is available. Then readable VI. This file connects the retrieval stage with the generative AI stage. This is where the actual RAG process comes together. Okay. Then look for this line. I will discuss only the important part of this code. I have not enough time to describe each and every part of this program. So I will discuss a few most important things in this part. The concept which is used here. Has the user question in this part? See this part. I will discuss about this. Has the user question is converted into an embedding. The embedding is passes to the vector search function. The vector database return the most relevant chunks. Then relevant part. See this. In this part, I then apply a distance threshold. The purpose of this step is to remove results that are not sufficiently relevant to the question. If there is no sufficiently relevant information, the system does not try to invent an answer. Okay, then see this. This is an important part to making the system grounded. If the information is not found in the uploaded document, the application tells the user instead of predicting that the information exists. Then context. See the context. Here I combine the retrieve chunk into one context string. I also include the page number. The context become the information that is given to Gemini. System Okay, here I use to system prompt. I also created a system prompt that tells Gemini how it should behave. The important instruction is that the model should answer using the retrieved document context. If the information is not available in that context, it should clearly say that I could not find the information in the uploaded document. This helps keep the answer grounded in this user story material. This is model what Gemini I use here. After retrieving the relevant information, I used Gemini model to generate the final response. Generate the final response. Response. The model received three important pieces of information: the system instructions, the retrieved context, and the user question, and then respond accordingly. This is the core generation step. Gemini does not receive the entire PDF, it is receive only the relevant context retrieved from the vector database. This is the main idea behind retrieval augmented generation. What is RAG? Sorry. Now I will briefly explain what is RAG means. RAG stands for Retrieval Augmented Generation. I combine two major processes. The first is retrieval. The system retrieves relevant information from the user document. The second is generation. Gemini used that retrieved information to generate a natural language answer. So instead of asking the AI to answer purely information from its printing written knowledge, I first provide it with relevant information from the user own document. Then I will give that relevant information to the Gemini and take the answer from that. This is the architecture section of this project. The complete pipeline of my project works like this. First, the user upload the PDF. Then the PDF go to the fast API backend. PY PDF exert the text. The text is divided into small chunks. Then each chunks is converted into embedding using sentence transformer. Then these embedding are stored in Chrome database. Then when the user asks the question is also converted into an embedding. Chrome database performs similarity search and finding the most relevant chunks. These chunks are provided a context to Gemini. Gemini general the final answer and the final answer and finally the answer and its source are returned to the React frontend. Now stop explaining code and demonstrate the actual website. Let's show our project how it works. See, this is my project, and after I click in the story, it come like this. The application I accept PDF file and send the selected file to the backend. The backend exert the text created chunks, generated embedding, and stored them in Chrome database. Once processing is completed, the interface so that the document is ready and display the number of chunks created here. Then enter the question and it gave the answer. Okay. Now I will show one of the example. I will give here a HTML file which name is trial.pdf. When I uploaded that file, then after successfully upload the PDF, it is so like that, and this chunks is nothing but it is the part in which how many part the PDF file is divided. And I ask the question is what is HTML, then the response of this AI is like that, and at last it also show the page number where the user can also find them. Yeah, like I will now ask a question that is not related to the upload document. That is, let's nominate. I could not find the information in the upload because there are no anything word in that document that is named nominate. That's why it is so like that. Okay, finally. To summarize the technical implementation, the front end is building using React, TypeScript, Vite, Tailwind CSS. The backend is used using Python and FastAPI. UI PDF is responsible for PDF text extraction. The splitted, divided and exact text into mm, meaningful chunks. Sentence transfer converted those chunks into embedding. Chrome database stored the searches these embedding. Similarly, search retrieves the most relevant information. Finally, Gemini used the retrieve context to generate the natural language answer. This completed process from the retrieval argument generation pipeline (RAG) pipeline. Why this project used RAG? Anything else? Why this project is used RIG? The main advantage of using RIG is project in this project is that the AI can work with information from the user own document. This makes the system much more suitable for document based question answering than simply asking a general purpose AI model without providing document context. It also allows the system to provide source information and reduce the chance of generating information that is not present in the upload story material. In the conclusion part, I would like to say so this was my project StoryMind AI Pro, an AI powered PDF question answering system based on the retrieval argument generation. Through this project, I implement the completed pipeline from document processing to AI based question answering. The project helped me understand practical concepts such as PDF processing, text chunking, embedding vector database, semantic search, fast APIs, React front-end development, and generative AI. The main learning from this project is that building an AI application is not only about using an AI model. We also need a completed pipeline that prepare the data, retrieves the right information, and provide that information to model in the right context. Thank you for watching it. Then we'll move towards the minor project. Okay. Hello everyone. My name is Navneet Pereda, and in this video I am going to explain my minor project SpamShield AI. SpamShield AI is text classification application designed to define whether an email or text message is spam or leg or not spam. In this project, I have focused on the completed flow from entering a message to analyze its context and displaying the prediction with a confidence score. I will explain the project objective, technology used here, the application make important part of the code, and finally I will demonstrate the website. Okay. The main objective of SpamShield AI is to demonstrate how text classification can be used to define definitely unwanted or suspicious message. Spam messages commonly contain words and patterns such as promotional offers, price, urgent request, link, or requests to verify information. The application analyzed this entered message and classified it as either spam or not spam, along with a confidence percentage. Then eh, let's go to the code part. Okay. For this project, I used a modern front-end based architecture. The main technology is React with TypeScript, which is used to build the user interface and manage the application state. I used Tailwind CSS for styling and responsive design. I also use Logic React for icons. The project is structured into reusable components such as a navbar, euro section, spam detector, information section, and footer. The project information as also describe the machine learning concept using Python and Scikit-learn, which the current website demonstrate perform the application locally using a lightweight rule-based prediction function. Okay. Look at this folder permission. The main application code is inside the sh folder. After tst is the main component that combines the different section of the website. The hero.txt file contains the main load. Spam detector, the TST contains the actual interactive spam detection function. Info section, the text contains the how it works and model information section. Now, but the TSX manage the navigation bar and footer. The TSS contains the footer section. The component based structure make the application easier to maintain and modify. Okay, let's discuss about this function. Sorry, this file. Okay, from start. The end. Okay, it is the ending part. It is the starting part. Okay. This is the main app.tsx file. I import use ref from React because I use a reference to navigation to the spam directory section. The application imports the main components such as navbar, hero, spam director about how it was, and model information. The app component then combines this component to create the completely page. This keep the application modular instead of putting the entire website into one large file. Then we'll go to the hero the tsx. Okay, look this function. This file create the hero section of the website. I used to TypeScript interface called hero props I to define the function that is passed to the component. The hero section introduces the project which the message detects spam before it reaches you. It also provides the main button that takes the user to spam director. The icons are imported from Louis React to make the interface more visual clear. Info sections, the TSX. Let's say what the file contains the education information displayed on the website. The steps error defines three main stages of system. First, the user enter a message. Second, the message is analyzed. Third, the system proceeds a spam or harm prediction. I also created a model information array containing information about the algorithm input, output, and technology. Using array and mapping make this section reusable and easier to update. Most important is spam detected the TSX. Now I will explain the most important part of the project, which is spam detected component. See this part and see this first in this function. Okay. I use React use state how to manage the application state. Message stores the text entered by the user. Redirection store the application result, and analyzing is used to control the loading state while the message is being analyzed. Suspicious words like This is a suspicious word. From that, the muscle learn it is a spam or not. This array contains common terms that can indicate suspicious or promotional message. When a user enter a message, the application check whether this term appear in the message. The number of matching suspicious term is then used as one of the factor for the classification. Then predict message function. See, the function is responsible for generating the prediction. First, the message is converted to lowercase. This is most important. It makes the matching case in insensitive. For example, winner means the capital letter total capital letter converted to into lowercase, and the winner. I hope you understand. Then const match. Khatarnak. Const match. Next, the application check each suspicious term against the message. The filter function keeps the term that are present in the message, and length gives us the total number of matches. So the variable represents how many suspicious patterns are detected. Then const looking spam. This is main classification condition. If the message contains two or more suspicious terms, it is considered like to be spam. There is also another condition for message containing a web link together with at least one suspicious term. If either condition is true, the application classifies the message as spam. Confidence true. Confidence. The application then calculates a confidence score for a spam message. The confidence increases when more suspicious terms are detected. For example, without this pattern, the application generates a l- higher prediction. Otherwise, it is and math that main is used to keep the confidence within a maximum limit. Okay, then look for this. Finally, the function return the classification. If the message looks suspicious, it returns spam. Otherwise, it returns harm, which represent a legitimate or non-spam message along with the level 80 also return the confidence score and a short explanation. Then analyze. When the user click the analyze button, the function is called. First, it is check whether the input is empty. Then it activates the mess, analyzing the state and clear the provided result. After that, the prediction function is called and the result is displayed to the user. Then we will go to the website and demonstrate it. Try message. Sorry, try detector. We'll write a message that okay, let's uh, give some spam and say okay. Let's check it is spam or not spam. See, spam email and confidence level is 98 percentage. Observe it. Then not spam message like that. Sorry. See, not spam. Okay. I hope you understand well. Here I okay, I will tell you overall. So the completed workflow is of SpamShield AI is very simple. The user first enter an email to the text message. The application then normalize the text and the check is against suspicious storm and patterns based on the number of detection pattern and the presence of links. It generates a spam or harm prediction. Finally, the application displays the result confidence score and reason of the user. Conclusion. In the conclusion, Spam Cell AI demonstrated the basic concept of the text classification for spam detection through the project. I implement a clean React and TypeScript interface, reusable component state management, text analysis, logic classification, and confidence-based result. The project helped me understand how natural language text can be processed and how classification logic can be connected with the friendly, user-friendly web application. Thank you for watching my project presentation. Thank you very much to all to see this project. I hope it is. And at last, I tell you something. I get this project from the Pregrade platform to complete my program of AIML. So thank you, sir. Thank you everyone for watching this. Thanks a lot.